Homework 4.4 Exponential and Logarithmic Equations, Video 8. Homework due Friday, May 29th at 11:59 p.m. This video and the previous video are associated with homework questions 16 through 20. In the previous video, we looked at an example of a logarithmic equation that had logs on both sides and refined our technique to accommodate that. In short, condense each side, cancel the logs, solve, look for bad answers, answers that make a non-positive argument. Oh my, that's my George Takei impersonation. Solve natural log of x minus 2 minus natural log of x plus 3 equals the natural log of x minus the natural log of x plus 7. You know, I'm jokingly being intimidated by the size of this problem, but I'm not, and frankly, you shouldn't be either. A lot of people have a misconception that big math problems are hard math problems. Big problems are not hard problems in general if you have a strategy and you can stick to it. The size of this problem is completely irrelevant. As long as I have moves that I can execute, one move at a time, when it's all said and done, not a problem. So where do we begin? Well, we have logs on both sides. We should condense both sides. Because we have 2 logs on the left and 2 logs on the right. So now we have to stop and think, what are the rules we can use for condensing? Product rule, quotient rule, power rule. On the left, which rule should we use? Hint, there's a minus. Answer, quotient rule. So we're going to use the quotient rule, if I can spell quotient, on the left, and honestly, on the right also. So quotient rule on both sides. I guess I should write the words rule after the words quotient. So let's condense. And remember how the quotient rule goes. If you have a difference of 2 logs, you can condense them into 1 log of a fraction. The positive logs argument goes on top. The negative logs argument goes on bottom. Natural log of x minus 2 over x plus 3. Don't you dare cancel those x's. All right. And on the right side, we have another quotient rule. So natural log of a fraction. The positive logs argument goes on top, so x on top. The negative logs argument goes on bottom, so x plus 7 on bottom. And on the right, we have the natural log of x over x plus 7. Again, don't you dare cancel those x's. What's next? In one word, cancel. Technically, we're taking advantage of the fact that logarithms are 1-to-1, but visually, you could just say cancel the ln's. X minus 2 over x plus 3 equals x over x plus 7. And now for the fun part. Solve. You know, it's problems like this that make people go, math is hard, I can't do math. Don't give up so easily to it. I mean, think. And this is a problem-solving technique in general. If there is an obstacle, ask yourself what move overcomes it. The clear obstacle in this equation are the fractions. How do you overcome fractions in equations? By not thinking of them as fractions, but as division problems. For example, if I wanted to get rid of the fraction on the left, I will have to do the opposite of dividing by x plus 3. And the opposite of dividing by x plus 3 is multiplying by x plus 3. But if I do it on the left, I do it on the right. Stay calm, stay focused, let it come into view. Oh, but wait, there's another fraction on the other side. Can I cancel these? No. Can I cancel the x's? No! These x's are not parts of multiplication problems. They are not eligible to cancel. There's only one thing that will cancel in x plus 7. Another x plus 7. So same thought process. To get rid of a divided by x plus 7, I need to multiply both sides by x plus 7. It's getting a little crowded over here, but that's okay. Now I can cancel the x plus 7s in their entirety, and let's see what's left over. On the left side of the equation, I have parentheses x plus 7, which I multiplied by but didn't cancel. I needed to multiply for over here. And I also have the x minus 2. On the right side, I have this x, and I have this x plus 3, which I multiplied by but didn't cancel because I needed it on the other side where it did cancel. So now I have x plus 7 times x minus 2 equals x times x plus 3. What's the main obstacle now? All the parentheses. So what are you going to do about it? Distribute over there, FOIL over here, which is still just distributing. Okay, x times x is x squared. Let's go ahead and do the outside and inside and combine them. X times negative 2 is negative 2x. Positive 7 times x is positive 7x. Negative 2x's and positive 7x's is positive 5x's. And then the last part of FOIL is positive 7 times negative 2, which is negative 14. Oh goody, a quadratic equation. It's like every time we fix one problem, we create another. Don't worry, at some point, all problems will be solved. On the right side, it's just the distributive property, and we get x squared plus 3x. Now what's the obstacle? It's a quadratic equation. How do we attack that? Probably get it equal to 0. So, let's empty out one side of this quadratic equation. Do you want to empty out the left side or the right side? Normally that decision is based on getting rid of the smaller x squared and leaving the other one positive. But if you notice, these x squareds match. So when I get rid of one, it will get rid of the other. So there doesn't seem to be a clear-cut decision on which side to empty. Let's empty out the right side. Let's subtract x squared from both sides to get rid of the x squared here, and subtract 3x from both sides to get rid of the 3x over here, and that will empty out the right side of the equation, give us 0, because all that cancels. But that's not the only thing that cancels, so do these. And that leaves me 2x minus 14. Our quadratic equation suddenly isn't quadratic anymore. Hooray! And this is so easy to solve, I'm just going to finish it verbally and write the solution. Add 14 to both sides, you get a 14 over here. Then divide by 2. 14 divided by 2 is 7. So it wasn't that bad. But again, I like problems like this because they really give me an opportunity to say things like, math is about problem solving, but problem solving is more than just math. There will always be problems that you have to solve, period. Need a new job, need to find a better babysitter, need to get my car fixed or things like that. And problem solving, no matter the context, is always, here's the state that I'm in, here's the state that I want to be in, what is in the way and how do you overcome that? Now, I will admit that in math, sometimes it's easier to overcome those obstacles than, say, you need better daycare and you don't have the money to pay for it yet. But it's still the same idea. There's an obstacle in the way. What means can you take to overcome that obstacle? But we're not done, because we just did step 3. We still have step 4, discarding the solution. That caffeine is finally kicking in. Good, I was feeling lethargic up until now. Good thing I have one more series of videos to record. Do any solution, does the solution make an argument non-positive? Well, let's just check. If I put 7 here, 7 minus 2 is positive, so it's good. 7 plus 3 is positive, it's good. 7 is positive, it's good. 7 plus 7 is positive, it's good. It's good everywhere we put it. The 7 is the solution and the problem's over. I believe this is probably the hardest one in your homework, maybe with the exception of the substitution questions, but I have confidence that you'll either overcome them or you'll contact me if you need some help. There will be one more series of videos, but it will be from chapter 5, so you're going to see almost a completely different type of problem, mostly different.